We'll start. Okay, I'll make a quick revision about those things, and then we will just look at what to do. Now, tell me, what is the equation for SHM, a body moving in SHM, position of body. So let me just write up here, position. So position. क्या हो गया? Okay. So position, velocity, and acceleration. Okay, 1 second. Tell me, what is the equation for position? General equation.
Sir, x equal to a sin omega
equal
t
to a
plus
sin omega
phi.
t plus phi.
Okay, okay. What is this? Position, velocity, and acceleration. So we'll be studying about these three and see how to solve the problems related to these questions involving position, velocity, and acceleration. Now, position, general position is x equals to, tell me.
A
X
sin omega
equals
t plus phi.
A sin omega t plus phi, where all these parameters are known to you. A is the
Yes,
amplitude.
sir.
A is the amplitude.
Amplitude.
Omega,
Angular frequency.
angular frequency. And phi is what?
Initial phase.
Initial phase.
Initial phase. What do you mean by initial phase? When t equal to 0, if you put the value of x, you'll get the value of phi. For example, when you start looking, if in your initial time at t is equal to 0, if x is 0, phi will be 0, right? Because this will become 0. So you'll get sin phi into a equals to 0. So this value will come for phi equals to 0. So initial phase is phi. But when you start looking, if the position is at plus a by 2, okay, then phase may be either 30 degrees or 150 degrees, right? Because both are 1 by 2, right? Sine of 30 is 1 by 2, sine
Yes,
of
sir.
150 is also 1 by 2. Now the question is, what is it? Is it 30 or 150? That will depend on velocity. Whether velocity is in this side while you are looking,
Yeah.
or velocity is in this side. So if velocity is on this side, then it will be 30. If velocity is on this
30.
side, then it will be 150. Clear?
Yes, sir. Got it.
And so on and so forth. If minus 1 by 2, then phi will be minus 30, and so on and so forth. Anyway, we'll look at that in detail. What about y equal to? Sorry, v equals to. V is what? A omega cos omega t
Yes, sir.
plus phi. How
Yes,
did you
sir.
get this?
Derivative of x.
Rate of change of position is velocity. So if you take the derivative, okay. So here I'll
Yes,
write
sir.
v is also equals to dx by dt. So if you do this, you'll get this. So I'll actually write this first, then I'll write this. Okay.
Okay, sir.
Now, what will be the acceleration? Tell me. Acceleration
Equal
equals
to minus a omega square sin omega t plus phi.
First, I'll write dv by dt because acceleration is rate of change of velocity. So what is a?
Minus a omega square.
Minus a omega square sin omega t plus phi.
Minus a omega square sine
Omega t plus phi.
omega t plus phi. So this will be your acceleration, expression for acceleration. Okay. Now,
Yes.
Sometimes he'll ask you a question which is like this. I'll show you. Now, what does A depend on? A depends on whatever amplitude we give to the system. Okay,
System.
we can leave the mass by displacing by this amount, or we can displace by this amount, or we can displace by this amount. So whatever amount of amplitude we give in the beginning, that amplitude will remain. So this is in our hands. Okay, what will
Yes,
phi
sir.
depend on? Phi depends on, what is our initial time of observation. Okay, so you can start observing while it was at mean position, you can start observing while it was at extreme position, or you can start observing while it was somewhere between extreme and mean position also. So phi will depend on actually what your initial time of observation is, instant of observation is. And omega will depend on the system. This is not in our hand. It will depend on mass and K for a spring mass system, and it will depend on L and G for a simple pendulum, and for physical pendulum it will depend on I and distance between center of mass and axis of rotation, about which it is
Yes.
doing SHM. Clear? So about that physical pendulum we have seen in one class. We'll come to that later. We will redo those problems. But now let us do the problems involving position, velocity, and acceleration. Now he'll give you a problem like this. So the problem is this. For a body in SHM, for a particle in SHM, it was observed that V1 was 3 meters per second when position was say 4 centimeters. Okay, when the position was 4 centimeters. What is mean position? Mean position is 0 centimeters. Okay, clear?
Yes, sir.
Yes,
And
sir.
one more reading will be given, and velocity was 4 meters per second. Velocity was 4 meters per second when position was 3 centimeters. Okay, or when
Yes, sir.
this thing displacement was 3 centimeters from this mean position. Okay,
Yes, sir.
he will ask you, for this SHM, find the amplitude and omega, or find the amplitude and time period. Okay, so the question
Okay,
is this:
sir.
find omega T A. So we have two sets of information. At one instant, velocity was 3 meters per second, and displacement from mean position was 4 centimeters. Second set is one more instant. At some other instant when they saw, the velocity was 4 meters per second and the displacement from mean position was 3 centimeters. Now he's asking you what is omega T and A. Okay, and one more thing, these values can be positive or they can be negative also. Clear? But in this particular
Yes, sir.
question, the values given are positive. Okay, now let us see
Yes, sir.
one more thing. Okay, I'll come to that later. Now let me write the equation. What is x equal to? A sine omega t plus
Omega
phi.
T plus
plus
phi.
phi.
Okay.
Now two equations we have to put x1 equal to, then x2
Oh, wait,
equal to.
no. Before that, let me derive one,
Okay.
relationship. Let me derive. Okay, and v equals to a
A
omega
omega cos.
cos omega t plus phi. Okay, and there is one equation, very famous equation, with which you can eliminate sin theta and cos theta. What is it? Sin square theta plus cos square theta equals to 1. Trigonometric
One.
identity.
Yes, sir.
Then 1
Squaring and
minus
adding
sin
both
square.
equations.
Okay, fine. So what I'll do is, because I can eliminate this sin and cos, I'll write sin of omega t plus phi equals to, tell me, from the first equation. Tell me.
Minus cos of omega t plus phi.
X by A.
X by a. Okay,
Okay, yes, sir.
and cos of omega t plus phi is
V by A omega.
V by A omega, correct?
Yes, sir.
Yes, sir.
V by A omega. Now we know that sine square theta plus cos square theta is 1.
Yep.
Yes, sir.
So sine square of anything plus cos square of anything is 1, right?
Yes, sir.
Yes.
So here what we get? X by A whole square. Okay.
Plus V by A omega
V
whole
by-
square equal to 1.
V by A omega whole square is equal to 1. So you will get one relation which you can remember
This
so
is an
that
ellipse.
you'll have you will require less time to solve the problem in exam, because you shouldn't do all this in exam. You have to remember. What you have to remember is this. See, this one, x square. So this is square. Okay. So x square omega square. I'm taking LCM plus v
Oh,
square
yes, sir. X square omega square plus V square
equals
equal
to
to A
a
square omega square.
Clear? Okay.
Yes, sir.
Are you clear with this?
Yes, sir.
Yes, sir.
Okay. So here, what can you do? You can use this equation and solve. Okay. So x square omega square plus v square equals to a square omega square. Okay. Clear?
Yes, sir.
Now, if you write the first equation, first set of values, what will you get? X1 square omega square plus
Plus V1
V1
square
equals
equal
to
to
a square omega
A
square
square omega square.
x2 square omega square plus v2
We can
square.
equate both equations.
Okay. We can you can equate both the equations. So what will you get?
Okay,
Tell me.
X1 square omega square plus V1 square equal to X2 square omega square plus V2 square.
Okay, fine. So I'll write x1 square plus x2 square times omega square.
Class चल रही
Plus v1 square plus v2
कहाँ के
square.
राजा अब उन लगा के करना तेरे को अपन जाके बता
1 second. Both are equal, right?
Yes, sir. Both are equal.
So x1 square omega square plus x2 square. Okay, x1 square omega square plus v1 square is equal to x2 square omega square plus v2 square. Clear?
Yes, sir.
So here, what will you get is omega square, if you take common, x1 square minus x2 square equals to v2 square minus v1 square. I'm just bringing all the v's to the left side and positions to the left side. Clear?
Yes, sir.
So you have to remember this also. Okay?
Yes, sir. Got it.
Actually, no need to remember, but if you remember, it will be, time saving in exam. Okay?
Yes, sir.
Now tell me what is given in the question. Omega square, we have to find this into x1 is given as 3 centimeters, right?
Yes, sir.
Three
X2 is 4.
Sorry,
No,
4
X1 is 4, X2 is 3.
4 centimeters. So I'll take in SI units. So it is 0.04 square minus 0.03 square. Clear?
Yes, sir.
Equals to v2 square minus v1 square. What is v2 square? Where is v2? Here.
V2 is 3. Meter per
V2
second.
V2 is 4, V1 is
Yeah.
3.
Okay, okay.
So, and just think about it. You know, if position is the value of position is higher, velocity will be lower. Common
Yeah,
sense.
I thought so.
Because you know, if x is more, it is away from mean position. It is near extreme position. Near extreme position, velocity will be less. For a higher value of x, value of v will be lower. For a lower value of x, v will be higher because it will be close to mean position, right?
Yes, sir.
Okay. Anyway, here you will get you know, omega square by, I think by 100. 4 by 100 is 10 power 4 common. I'll take. Okay. So 4 square minus 3 square I'll get, right? Okay. Fine.
Okay, sir.
Equals to 4 square minus 3
Yes,
square.
sir.
So anyway, this will cancel. So omega is what? 100. Can you see that?
Yes, sir.
Square root of 10 power 4 is 100. Okay. Clear? See, this will cancel. Omega square by 10 power 4 equals to 1. So omega square equal to 10 power 4. So omega equal to 100, right?
Yes.
Yes, sir.
Fine. We got omega.
sir.
Now we want to find A. How to find A? You substitute that omega in any one of the equations, you will get A. Okay. Clear?
Yes.
So
Yes, sir.
I'll equate in the first equation. What is first equation? First set of values. In equation 1. Okay.
Yes, sir.
Okay. Anyway, next page I'll do. So find A using omega. Now, if you want to find A using omega, I'll use this equation. So what is x1? X1 is 4 centimeter, right? Clear?
Yes, sir.
Yes.
So x1 omega square. So 0.04 into omega square plus v1 square. V1 square is how much? 3 meters per second. Clear? Equals to a square omega square, right?
Yes, sir.
What will you get? Tell me. What will you get? 0.04 into 10 power 4 plus 3 square equals to a square into 10 power 4, right?
Yes, sir.
So I think
14.
what will you get? Right on the left hand side, because 0.04, no, you'll get 40 to 10 power 4 is 40, na? 400. Is it 400?
Yes.
Okay, 400 plus 9 equals to a square into 10 power 4. Is it correct? X1 square. Okay. I didn't write square here.
Yes,
I
sir.
should write square here. Now tell me. So it will be 10 power 4 and that will cancel. I think it will be 16, right?
16. Yes.
Yes, sir.
Okay. So this will be 16 into 10 power minus 4. Okay. So this will be 16. So I'll get 25. Okay. Okay. Fine.
Yes, sir.
Yes.
So 25 by 10 power 4 equals to a square, implies
1
a
by
equals to a is equal. What is a equal to? Implies
plus or minus 1 by 2.
a equals to I think it is 5 into 10 power minus 2, right? Meters. So it is actually 5 centimeters, right? Clear?
Yes, sir.
Calculation, did you understand?
सर
One
लास्ट
Yes.
का एक बार कैसा है, एक बार बोलो.
इधर स्क्वायर रूट करो, इधर a आ जाता
ओके
और
ओके
इसका
सर.
5 आता और नीचे 10 पावर 2 आता, तो 5 into 10 पावर minus 2
10 power minus 2 आया था.
SI यूनिट्स में है, इसीलिए मीटर है. सेंटीमीटर में करे तो 5 सेंटीमीटर. क्लियर?
गॉट इट सर.
Yes, sir.
So you have to remember this relationship. Which relationship? This one. This one. Otherwise you can do. Okay. So better to remember this. Omega square into x1 square minus x2 square equals to v2 square minus v1 square. Okay. So from that you will
Okay,
get
sir.
omega.
Yes, sir.
That you will get omega. And after that, what you do is you'll have two equations, right? One is this. Another is this. Either of them you can use and you can find it. Clear? Okay. Now, what is time period? 2 pi by omega. So what is time period? 2 pi by omega was 10 power. Omega was 100. Correct? So implies time period is what? Tell me.
Pi by 50.
Pi by 50 seconds.
Yes, sir.
Okay. So you go through this problem multiple times because this is very commonly asked question in exam. Okay.
Okay
Clear?
sir.
Fine.
Yes sir.
Fine. Now, what about acceleration? What about acceleration? Relationship between acceleration and okay, I'll write both. Relationship between velocity and or position and velocity. Tell me, what is the relation? Fast. Here, this relation. Okay, this is the relation. This is the relation between velocity and position, right?
Yes, sir.
So let me just write it in a little bit different way so that it will be easier to remember. So I'll just rewrite this and I'll simplify it. So x square plus, tell me. X square omega square. X square omega square plus v square equals to a square omega square, right? Don't remember this in this form, you'll forget. Better you remember like this. You take omega square, you take v square on this side, you take omega square common and you write here a square minus x square. You remember this. Okay. So this is important. This is the relationship between v and
Omega.
no, v and x. Omega
Okay.
and a are parameters of the this thing, SHM.
Yes, I got it.
So v square is equal to omega square into a square minus x square. So you can write two equations, right? If in the problem v1
Yes,
square
sir.
is equal to omega square into a square minus x1 square, v2 square is equal to omega square into a square minus x2 square, and then you can solve this to get what? A. How will you solve? Just divide both equations, omega square will cancel, a will remain, and you'll find a. Okay. After finding a, put the value of a in either first equation or second equation to find a. Clear?
Yes, sir.
So here I'm writing, if two sets of values are given, two sets of values at two instants is given, say x1 v1
x2 v2
and x2 v2. Okay, substitute to get two equations. Divide, substitute to get two equations, then divide second equation from the first equation to eliminate omega and get A. Correct?
Yes, sir.
After that, what will you do? So after getting A,
equate both equations.
no, substitute A in one of the equations to get omega. Clear?
Yes, sir.
It's quite simple. You remember this equation. You substitute v1 equal to omega, v1 equal to omega square a square minus x1 square. You'll get first equation. Then you substitute second values. So you'll get second equation. Clear? Now divide the first equation from the second equation. Okay? x1 square. So omega will get eliminated.
Okay,
You will find A. Okay? After finding A, put that value in one of the equations, x1, v1, to get the value of omega. Clear?
Yes, sir.
Okay. So this is relationship between x and v. Now let us look at relationship between to eliminate omega, divide second equation from the first equation to eliminate omega and get it. Okay. Clear?
Yes, sir.
Now tell me what will be the relationship between A and X. Tell me. Small a and x. Tell me fast.
Minus omega square x.
Yes, yes. That was the main equation that we learned
Yeah.
in SHM, right? So
Yes,
the
sir.
equation is A equals to
Minus omega square.
omega square x. Clear?
Yes, sir.
Yes, sir.
Now, if values of A and X are given, you can find omega, right? Only one set of values is enough. Are you understanding? So the above equation can be used to find omega if a set of A and X are given. Are you following?
Yes, sir.
But you cannot find the value of amplitude using the set of, even if he gives two sets of values of A and X, you cannot find the value of amplitude. Can you find? Suppose he gives you x1, a1 and he gives you x2 a2. He's giving you two values. Can he give? Tell me.
No,
So can I
sir.
repeat the question?
Suppose he gives you two sets of values.
Yes, sir.
Suppose he gives two sets of values of, like, see here, two sets of values are given. Which values of velocity and position are given?
Velocity and position.
Using those two sets, you found out not only omega, but you also found out a. Clear?
Yes, sir.
Yes, sir.
Here, no matter how many sets of accelerations and displacements are given, you cannot find amplitude here. You know why? Because there is no capital A in this equation. Okay?
Yes, sir.
Clear? So using the values of accelerations and displacement, sets of values, it's impossible to determine the value of amplitude, but you can determine value of omega only if one set is given. Enough. One set is enough. Okay? Acceleration
Yes,
will
sir.
be given and position will be given, and you can find out what omega is. Clear?
Yes, sir.
Okay?
Yes, sir.
And what is the relationship between V and A? Tell me. Okay, what is the relationship between V and A? Can you guess?
V is equals to A omega.
Let us just see. So relationship between A and V. So here we'll try to find out what the relation is. It will be almost similar to relationship between V and X. So I'll write first. What is V equal to? A omega cos omega t plus phi. Agreed?
Yes, sir.
Omega t plus phi.
Sir, are we going to write? No.
Tell me what is the equation for A?
Minus A omega square sin
Minus
omega t
A omega square.
Sin omega t
sin
plus phi.
omega t plus 5.
Okay, fine. Now again here you can eliminate sine and cos. Right? What is the equation which is used to eliminate sine and cos? Always. Sine square theta plus cos square theta is
1.
1.
Yes, sir.
That theta can be anything. It can be omega t plus phi also. Okay. So according to that, tell me what do you get? What will you get? V by A omega
Yes, sir. Whole square plus
plus
phi capital A omega square whole square.
even if minus you keep, it will anyway become
Yeah, it
plus.
will be 1.
So anyway, plus
A by capital A omega square whole square.
we'll write correctly. So it will be A by minus capital A omega. Even if you don't write, you'll get the same thing.
Yeah, but
But anyway, we'll write
not
just
for
for understanding.
confusion purpose.
Equal to 1. Clear?
Yes,
So
sir.
if you rearrange all this, you get, if you cross multiply, you'll get V, square is there. If you cross multiply, you'll get V square, okay, into A square omega power 4. Is it right?
Yes, sir.
Yes, sir.
Plus A square, small a square, okay, equals to A square omega power 4, right?
Yes, sir.
So is this equation correct? So at last, what will you get? Again, tell me.
So we can take omega square common. Omega to the power 4 common.
A square omega power 4 common you can take,
Yes, sir.
or I'll write
B square minus 1
a square on the left hand side. What will I get?
equal to a square omega power 4 common
omega
into 1 minus b square.
Into 1 minus v square. Is it correct?
Yes, sir.
I think there is a problem somewhere. I think there is a problem in LCM. See, I think this shouldn't come. So this should be just tell me what is LCM. LCM, if you take, you'll get only omega, I think, right? See, check it.
Yes, sir.
Because see, there is a omega on the term on the left and there is a omega square on the term on the right here. So only thing extra is what here? Omega, right?
omega.
That will go and multiply here and it will get squared because we have square on both sides. So you'll get v omega
sir.
square here. Okay. And LCM will be
Yes,
a
sir.
omega square, which is squared. So it will become a square omega power 4 and it will go that side. So this is the correct thing, right?
Yes, sir.
Now tell me what is a square equals to? Small a square equals to.
A square omega square minus v square
Like
omega.
minus v square omega square.
Okay. So omega square, if you take
Omega
common,
square common, yes.
what will you get here?
A square minus v square.
A square omega square minus v square.
Yeah, this is correct. A square omega square minus v square. So this is the relationship between A and V.
So,
Not very
sir,
important.
capital A square.
Where? Yeah, capital A square.
Square. Capital square.
All right, A omega whole square. Okay. Clear?
Yes, sir.
Yes, sir.
Because dimensionally, V is same as A omega. A is in meters, omega is per second, so it will be meter per second. Now it is dimensionally correct. Okay. Clear?
Yes, sir.
So
Yes,
this
sir.
this is the relation. So okay, I'll just write this on the previous page. No, I'll cut it. Okay. Okay, I'll keep this in previous page. Space is not enough. Clear? Okay. So all relationships I'm writing here. Okay. So all the relationships. So all equations relating x, v, a in terms of a and omega. Okay.
Yes, sir.
In terms of a and omega. Tell me first equation. So first between x and v. So what is the relation? Tell me. Yeah, tell me. X square Okay. V square equals to omega square into a square minus x square.
Yes, sir. A square minus, yes, sir.
A square minus x square. This is the first relation. Okay. Now, what about x and a? Tell me. A equals to? Tell me. Minus omega
Minus
x.
omega square x.
No, just minus omega x. Okay. This is the main equation for SHM, right? This is the equation that we use to find out the time periods of complicated systems, like, complicated or simple systems, like simple pendulum. And what else? Spring mass system, physical pendulums. And what else? Later you'll learn about, rolling bodies also, or multiple springs attached along with pulleys. All those things you'll learn later. Okay. Now,
Yes, sir.
last relation between V and A. Tell me, what is the relationship between V and A? We just derived, right?
A square equals to omega
Hmm.
square.
A square equals to omega square
Omega
into
square to
A square, A omega whole
minus
square
V.
minus V square, right?
Minus V square, yes, sir.
So this is the relation. So even if you don't remember these, you can use the definitions of, in terms of sine and cos, you can write, you can eliminate sine and cos and do the problem. But in exam, if you, what?
I mean, we can derive easily.
Yeah, you can derive easily, but in exam, if you remember, you'll save your time. That's all. Clear? Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, one more thing. Let us go back to finding time periods. Let us go back to finding time periods, but I'll show you a new method. I'll show you a new method. Our old method was what? Okay, for example. Okay, so the method of force and second law. Okay, so this was the method which we were using to derive the time period of different bodies in systems in SHM. Example.
Yes, sir.
Example. Spring mass system. Okay, what did
Yes,
you
sir.
do? Spring mass system. First, what did you write? F equals to minus kx. Clear?
Yes, sir.
By Newton's second law.
Yes, sir.
Second law, according to second law, F equals to minus ma.
M.
Sorry, F equals to ma. What did you do? You equated both. What did you get? Tell me. ma.
M equal to minus kx, A equal to minus k by m into x.
Sometime. Are you able to hear now?
Yes, sir.
Yes, sir.
Okay, give me
Yes,
some.
sir.
One second. So what did we do? We wrote the equation for force in spring mass system, F equals minus kx. Then what did we do? We used the Newton's second law. We wrote F equals to ma.
Sir, you are
We-
not sharing your screen.
One second, one second. Okay, tell me the method. First we write the force equation, whatever the force is. Then we use Newton's second law and write F equals to ma. We equate both the equations, force for both the equations. So we'll get ma equals to minus kx, a is equal to minus k by m into x. We get this, right? This is the standard SHM equation for SHM, right?
Yes.
Yes.
What is the
Yes.
standard equation? This equation, the second equation, a is equal to minus omega x, right?
Yes, sir.
So we compare it. We compare this equation with a is equal to minus omega square x.
Yes, sir.
Did I write omega square here? This is omega square, right?
Yeah, square.
Yeah, someone told omega square, but I forgot. This is omega square. Okay. Now, since see, you can also check the dimensions. This is meter. This is meters per second square. This is per second, right? Radians has no units, na? Radians is a dimensionless quantity. So basically, this is in meter. This is in seconds per second square. So meter per second square. Okay. You always check the formula whether it is correct or wrong using dimensional analysis. Okay. Clear? So you'll use this. Using this, you will conclude that omega is equal to what? Therefore,
My
Root
K by M.
by
omega equals to root k by m. Okay.
Yes, sir.
Now you got this
Yes, sir.
omega. Okay. Omega equals to root k by m. After getting that, you can find the time period. Time period is 2 pi by
Yes,
1.
sir.
2 by M.
So implies time period is what?
2 pi by omega.
2 pi by omega.
Yes, sir. Which is equal to
By
2 pi
root m,
by 2 pi into root m by k.
root m by k. Clear?
M by
K.
K.
Clear?
Yes, sir.
Yes, sir.
Okay, fine. There is an alternate method which will be easier in different, complicated situations that I'll share now. That is extremely useful in complex situations. One complex situation also I'll discuss. So various number of problems you can solve in SHM, especially in, if problem is big in JE advanced or something. Okay, you can solve. So this method is called law of conservation of energy, finding time period or omega and t, finding omega and t using law of conservation of energy. Okay, so in SHM and total energy is conserved. Okay, that means when kinetic energy decreases, potential energy increases. When potential energy increases, kinetic energy decreases. Are you understanding?
Yes, sir.
So I'll explain one situation. Okay, let me take one here. No, not this. Okay, I'll take this only. But I'll take Okay, wait for some time. Wait for Azan to over. Start. Main position, extreme position, main position, this extreme position. It has come back. Okay, fine. Okay. Now, can you see that the equation is starting at, the SHM is starting at mean position? Can you see?
Yes, sir.
SHM is starting at mean position. It is going to the extreme position on the right. Okay. And then it is coming back to the, here. See, first it was at mean position.
Yes, sir.
It has come to extreme position. It has come back to the mean position. And again, it has come back to the mean position. Now one cycle is complete. One cycle is complete.
Completed.
Okay, let me just. Okay. Now tell me one thing. Can you tell about the velocities, directions of velocities? First velocity was in right direction. Okay.
Yes, sir.
Here the particle started moving on the right direction. And in the second case, velocity will be 0. In the third case, velocity is in the third situation, the velocity is in the left direction. In the fourth, again, velocity is 0. And in the fifth, it is on the right direction. Clear? Okay. So this is the direction of V. Clear?
Yes, sir.
Now look at this. Here, kinetic energy is maximum, potential energy is minimum because the spring is not stretched. I'm talking about potential energy of the spring. Okay. So this potential energy of the spring constant of, okay, all right. Spring constant is K and mass is M. Spring constant is mass is M.
Yes, sir.
Now tell me, in mean, when it is in mean position, what is the extension of spring? 0. If extension of spring is 0, if it is in its natural
Sir, we cannot hear you.
Sir,
Like,
One second, it got disconnected. Wait for a minute. I'll just. Can you hear me?
yes, sir.
Okay, give me 1 minute. Okay. Okay. See, in the first case, the extension in spring is zero. Can you see that in the first case?
Yes, sir.
So in the first case, potential energy is zero and kinetic energy is max. Okay.
Yes, sir.
Why? Tell me why kinetic energy is max. Because if you
Yes,
write the equation for this, it will be x equals to a sine omega t, right? V equals to a omega cos omega t. Why is phi 0 for this SHM? A equals to, tell me, minus. Okay, we
Omega
don't require.
square.
If we don't require a, we just require v and x. Now tell me, why is phi 0? Because when you started looking at the SHM, it was at mean position. So when you put t equals to 0, you have to put x equal to 0. And if t equals to 0 and x equal to 0, phi will automatically become 0. That's why phi I didn't write. Okay.
Yes, sir.
Now here, potential energy is 0. Why? Because x is 0 at t equal to 0 initially.
Yes, sir.
And kinetic energy is maximum because when this will be 0, cos will have maximum value, which will be 1. That's why velocity will have maximum value of a omega. Clear?
Yes, sir.
Yes, sir.
Here, potential energy is potential energy max. And kinetic energy is 0 because it will stop at the extreme position, right?
Yes, sir.
Yes, sir.
Okay, fine. In the third case, when it is coming back, again, potential energy is
Zero.
0, kinetic energy is
Kinetic energy max.
max. And this and this will be equal, right? Because even
Yes.
if the velocity is in the negative direction, the formula for kinetic energy is what?
Half mv square.
V square. So the square will make it anyway positive. So we need not worry.
Yeah.
Yes, sir.
Yes,
Here,
sir.
potential energy is potential energy max.
Yes, sir. Kinetic energy 0.
Kinetic energy is 0. And in the last case, potential
Potential
energy
energy 0. Kinetic energy K max.
is clear.
Yes, sir.
So all these terms are clear, right?
Yes, sir.
Okay. Now tell me, what will be the equation for total energy or kinetic energy or potential energy? Okay, let me write down. Kinetic energy half mv square, right?
Yes, sir.
Which is equal to half m a square omega
Minus
square
x.
cos square theta, right?
Yes, sir.
Cos square omega t. This is the expression for kinetic energy. What will be the expression for potential energy? Half kx square. Okay,
Yes, sir.
which is equal to half k a square sin square omega t. Correct?
Yes,
Okay.
sir.
What is total energy? What is total energy? Potential energy plus kinetic energy, right? Following?
Yes.
Okay. Now let us just try to find out what total energy is. So total energy equals to potential energy is half k square sin square omega t, and kinetic energy is sorry. First let me write out. Let me write. Okay. Potential energy first. Half k a square sin square omega t, and plus kinetic energy is half m a square omega square
Cos square omega t.
cos square omega t. Now you know one thing. You know what relationship between k and m is, right? So we know that for SHM, for any SHM, omega equals to under root k by m, right?
Yes, sir.
Now from here you can find one thing. What? Relationship between k and m. So tell me, what is k equal to?
Omega
Omega
square into
square.
m.
Huh?
Omega square m.
into m.
Omega square m. Now I can substitute this in the equation of total energy, right?
Yes, sir.
So tell me, what will be total energy? Half
Half m
m
omega
omega
square
square sin
m
square omega t
square
plus half
plus half
m omega
m a square omega square cos square omega t.
cos square omega t. Clear?
सर ए बच रहा है ना ए
Sir,
स्क्वायर
a square.
Yeah.
एम्पलीट्यूड
Yeah. A is also there. 1 second.
Yes, sir.
So here a square is also there. I forgot. Okay. So a square. Now here sin square and cos square will be, there will be a common term. Common term is half.
Half m square omega square a square.
No, not m square. Half m omega square a square. And sin square theta plus cos square theta is
One
1.
only.
Okay. So total
Yes, sir.
energy. See, total energy is independent of time, and it is a constant value, right?
Yes, sir.
So total energy always will be, constant. That means total energy is conserved. Are you understanding?
Yes, sir.
And I'll write this in a different way also. This total energy. Basically, I'll use the same equation, relationship between omega and m and k. So can I write m omega square as k? Can I write m omega
Yes, sir.
Yes.
so m omega square as k. So total energy is also equal to
Half K square.
half k square. Half k square.
Half K square.
Half k a square. Fine. Now tell me one thing. What is maximum kinetic? What is maximum potential energy? Half k a square, right? Because x
Yes,
maximum
sir.
is a.
Yes, sir.
So this is potential energy max. What is kinetic energy max?
0.
No. Max, not min. Half.
M V
Half
max
K.
square.
Very good.
Yeah.
V max square. Very good.
Yes.
But what is V max square? A omega, right? A omega is V max, na?
Yes, sir. So A square omega square.
A
square.
omega square.
So can I write total energy is equal to Ke max and Pe max?
Yes, sir. There's some.
Because both the terms are there. So total energy equals to Pe max
Plus Ke max.
Ke max. Okay. Fine. Are you understanding this?
Yes, sir.
Yes, sir.
One more thing, one more question I want to ask you. What will be the frequency of energy? Here is the question. If the frequency of an SHM is F.
Sir, today's class time.
हाँ?
आज की क्लास टाइमिंग क्या थी?
क्या हुआ 5 हुआ
हाँ
5:15
5 हो. Yes sir, हो गया 5.
5:15 5:15 पे खत्म हो जाता. 1 मिनट नहीं तो ये टॉपिक के बाद खत्म कर देंगे. चलो 5 मिनट्स में.
Okay, sir.
So if the frequency of an SHM is F, what will be the frequency of kinetic energy and potential energy? Tell me how to do this. Is the sound audible?
Yes.
Yes, sir.
Yes,
Yes,
audible.
Okay, tell me.
So frequency
No, kinetic energy. Can you see that kinetic energy is something like sine square? Sorry, potential energy is something like sine square theta, and kinetic energy is something like cos square theta.
Yes.
Okay.
Yes, sir.
See. Okay. SHM में frequency क्या होता? Okay, let me instead of frequency, let us write
1 by
angle.
2 pi under root K by M.
Okay, 1 second. If the angular frequency of an SHM is omega, find the angular frequency. It will be a little bit easier.
Yes, sir.
Find the angular frequency. Potential energy and kinetic energy. Okay. Now,
Yes, sir.
you know that for any equation like y is equal to a sine omega t, frequency is omega, angular frequency is omega.
Yes.
इसका जो है ना ओमेगा रहता, right? If y is equal to sine of omega 1t, frequency will be omega 1, angular frequency. If it is omega 2t, frequency will be omega 2t. Clear? And time period will be 2 pi by omega, right?
Yes, sir.
So let me write down potential energy. Potential energy is half m a square sine square omega t, right?
Yes, sir.
Yes.
Now, because it is in the form of square of a sine, I decide what the frequency is. So what 2 by 2,
Yes, sir, we can write.
because this is the relationship between sine theta and cos 2 theta. Okay.
Yes, sir.
Yes, sir.
Remember, this equation. Which equation? This one. Sine theta equals to under root of 1 plus cos 2 theta by 2. Sorry, 1 minus. Clear? If I substitute that, I'll
Yes.
get. So what is potential energy? You'll get a constant here, half ma square minus 1 by 4 ma square into
Cos 2 omega t.
2 omega t. Correct?
Yes, sir.
So this thing will just lift the graph up because it is a constant adding to this. Okay, and this will be a periodic function with frequency 2 omega. Okay,
Yes, sir.
implies angular frequency is 2
Sir,
omega.
screen share
Correct?
stopped, I guess.
Yes, sir.
1 second. Okay, so this will just lift the graph up by some amount. This will be the frequency of this will be cos 2 omega. Are you understanding my point?
Yes, sir.
If you want, you can just graph and see that. For example, let me just. Okay, first I'll plot sine square. Okay, sine square x in this case. Okay.
Yes, sir.
Okay, first I'll plot sine x. So you see the period is 2 pi for this. What about sine square? Sine square will never be negative, first thing. Okay. Second thing, its period will be, its frequency will double. Its frequency will double. Let me show you. Can you see the frequency is doubling?
Yes.
You see, the green color graph, it is repeating for every 2 pi. The green color graph.
Yes.
Can you see that green color graph? Okay, I'll just switch it off. Blue, I'll switch it off. So green color graph is completing one cycle after 2 pi. 6 point something is 2 pi. Clear? This blue color, this whole cycle, this is one cycle complete. Okay, because from here again it is repeating the pattern. See. Okay.
Yes, sir.
Clear? Its period is, how much? Half. Period is half means frequency is double, na?
Yes,
Okay.
sir.
Yes,
And
sir.
one more thing you observe, this is the graph of negative cos lifted above. So negative cos will be here, above and below 0. This is lifted up because energy can never be negative. And we got the equation of negative cos. Remember? See, equation of negative cos. See, equation of negative cos. Remember? Here, negative cos value.
Cos.
Clear?
Yes, sir.
Yes, sir.
And logically, if you see, when the pendulum goes from mean position, it will come back here and it will come to the mean position. It will complete one cycle. That means its position and velocity will complete one cycle. But if you look at kinetic energy while going is equal to kinetic energy while coming back. Okay,
Yes, sir.
so it has completed one cycle in half of the time period only, na? The energy.
Yes, sir. Yes, sir.
So time period will become half. Okay, for energy, time period will be half of the time period of position or velocity or acceleration. Clear? That means frequency will double. Frequency will double. Clear?
Okay, sir.
So
Yes, sir.
frequency is double, 2 omega. See, if the question is asked, what is the frequency of potential energy or kinetic energy of SHM? You should answer 2 omega. If we ask what is the frequency, then you should say T by 2.
Yes.
That's
Yes.
energy and potential energy. And what about potential energy plus kinetic energy? It is constant. It is independent of time. Potential energy plus kinetic energy is
Independent of time.
Potential energy plus kinetic energy is, where did I write that? Here. Potential energy plus kinetic energy is independent of time. Where did I write? Yeah, here. So this is independent of time. Clear? So here, very important statement I have to write. Total energy is independent of time. Okay? So I'll write one more page here. This is the page, right? So total energy is independent of time and constant. Okay?
Yes,
Total
sir.
energy is independent of T and is a constant. What else? Total energy. Tell me. Total energy is equal to potential energy max is equal to kinetic energy max. Or what?
Yes, sir.
Energy, kinetic, that is where kinetic energy is max, right? Statement.
Equals potential energy
At
at extreme position.
extreme position. Clear? Everybody.
Yes.
So shall we continue tomorrow, because I didn't start the topic that I wanted to start.
Okay, sir.
What was that? Using the law of conservation of energy to find the time period of systems in SHM. That is very big topic. In fact, that topic will revise all the previous topics like rotation, like friction, like Newton's laws of motion. All those problems, the concepts of all those previous topics will be combined. Time periods of complicated systems, that we'll do tomorrow, next class. Clear?
Okay, sir.
Okay, fine.
सर वो ग्रिड लाइन से हटा के भेज
ठीक है.
और सर ये आप इन्वर्ट करके भेजना फिर से.
सर ये नोट्स भेज देते ना सर आप ग्रुप में.
भेजा था मैं.